So I have two mics. Thanks for organizing this event. Thanks for the coordination and thanks for inviting us. So we are from PricewaterhouseCoopers or PwC. Some of you guys might know us as a accounting firm, but we are from consulting practice. And within consulting practice, our group focuses on researching emerging technologies and demonstrating its capabilities. And eventually, we want to unlock the next new business values for our clients. So our mandate is to explore new analytics tools, techniques, and even principles. And we tend to focus on unstructured data such as image and audio analysis. And we also look into other different algorithms of AI or even reinforcement learning. Some of you might be familiar with different machine learning techniques. And we're trying to demonstrate all those great capabilities to different clients for their own usage.
So, it's a little bit of a setup. Thanks, Kay. So, basically, like Kay said, we are the Artificial Intelligence Accelerator at PwC, and our mandate is basically to solve client problems using machine learning and artificial intelligence techniques. So, our basic mode of expression, if I may call it that, is Python, and that's why we're here today. Before I move further into describing a few use cases where we actually use Python to do all of these, to solve these problems, how many of you are familiar with machine learning in a general sense? Okay, so that's quite a lot of you, as we can see. But for the uninitiated, just a brief on what machine learning is that machine learning basically refers to learning inherent patterns in data and using that to make inferences on, say, something like unseen data or like a new instance. So to give you guys like a basic example, what you see on your screen is like a scatter plot of data points. So these are apples and oranges that are being organized according to their size and color, which are basic characteristics of apples and oranges. So in a traditional technique, we would assess them according to these characteristics and place them somewhere there and try and figure out if an incoming object is an apple or an orange. But what machine learning does is it tries to learn the decision boundary there. So this is very simple for this particular example, right? We have an incoming data point, we see that it lies towards the right hand side, and that's why it's probably orange. But this becomes increasingly complex as we're dealing with, multiple characteristics that go into, say, a machine learning algorithm, or it specifically becomes super complicated when we're dealing with unstructured data. So when I say unstructured data, I'm referring to data that includes images, videos, again broken up into images or text, audio, all of these things. So we basically work on finding meaning in unstructured data and also sometimes structured data. So where does Python come into the picture? So we pretty much do all of these things using Python. So we've listed down a few of the libraries that we use on a fairly regular basis. So to do our basic operations, we use something like a scikit-learn, which gives us basic data mining and machine learning libraries that we can run our data through to find meaning, and then we use libraries like pandas for data structures to manipulate our data, and then NumPy to perform some matrix operations. But we also regularly use frameworks that are open source again, something that Google provides is called TensorFlow, which is their framework to enable end-to-end deep learning. And we use PyTorch, which is provided by Facebook. We use Keras, which is a neural network library again, which enables us to perform neural network operations in a fairly simple manner. So this allows us to quickly prototype and come up with solutions for different problems. We also use Python API for Spark language in order to scale all of the exercises that we do or the prototypes that we build, right? So now I'm going to show you a few use cases where we do all the things that we sort of spoke of. So this one's an example where we worked for an insurance pipeline company where our task was essentially to help them quicken their processing of automotive claims. So basically what you're seeing on the image is an incoming insurance claim photograph, and what we do is we apply deep learning techniques on this image to find out various different classes of damage and highlight the regions in the image which basically refer to these different kinds of damage and arrange them by severity, like you can see in the picture. What we also do is we detect different parts that we find in the image, and we also find detailed damages in the different parts that we've identified. So all of this uses deep learning techniques and is all coded in Python. To give you guys another example of something that we've been working on, so I showed you a model that uses machine learning techniques to come up with inferences and predictions, but a focus area of ours at PwC has specifically been to explain what the model is doing, or to try and kind of build trust in the outcomes that the model provides. So what you see here on the screen is sort of an under the hood look into what a neural network is seeing. So if you see on the left hand side, we picked an image of a gorilla, and on the right hand side, you can see that the classification result is that of a gorilla. In the center, we have, I don't want to get into the nitty-gritties of this because we're a short stack for that, but we're essentially trying to see what the network is seeing. And on the top right corner, we are basically highlighting pixels of the image, which were sort of most influential in making that decision that that picture was that of a gorilla. So these are kind of a few of the things that we do, and all of this is basically written down in Python. To give you guys a couple of more use cases, I'll pass it back on to Kate.
Alright, thanks, Kevin. So the previous example was one of our efforts to explain one of the complex AI models. And the explainability is really a big issue right now, especially with the trust of AI models and so on. If you follow AI-related news, you might have heard about different opportunities that AI can enable, but you might be also hearing more of the risk associated with AI. And it's actually a big concern as a society. As in PwC, we're trying to push toward a more responsible, ethical, fair, or even transparent AI model. And as a part of that effort, we worked on some kind of framework of guiding principles for all those. And to go with this framework, we developed the technical toolkits. And the example here, also building Python, is one of the examples that we have as a part of the toolkits. Basically, I'm pretty sure many of you are familiar with the neural network. This visualization is to explain and to be transparent about how the neural network is making decisions. And we built this example for in context of financial finance services clients where they use AI model, or more specifically neural network, to decide whether they want to accept or reject a customer or applicants for their credit cards. This is a very interesting case. I'm pretty sure many of you are familiar with AlphaGo case, where AI algorithm is winning human champions in many different complicated games. Definitely Go was one of the most complex games, and AI beat the human champion for that. We used a very similar technique for our clients. Basically, our client was interested in ride-sharing market using autonomous vehicle. We built a simulation because there's no existing market yet. We built a simulation and we trained the AI agent to act as an autonomous vehicle in the simulation. And AI model is really good at finding solutions in a very complicated situations and problem. So we let the AI figure out the optimal solution, and we learned from the AI agents based on how they react to different situations. And that insight gave us more strategies and tactics that our clients could deploy when they actually go to the market. And since I mentioned that AI is really good at finding solutions to very complicated games, and that also involves a lot of business cases. A lot of our clients use simulation models to analyze what-if scenarios. And we also use AI model as a part of the simulation to figure out what's the optimal actions that they can take in a given situation. I wish we had more time to talk about different cases, but this is, we'll pause here and we'll take any questions.
Round of applause. Killian, come on up while we get a question. Anybody have a question? Question. Anybody got a question? Nobody has a question.
I got one. How much, if at all, does PwC participate in open source?
As you mean, like as contributing to the open source community?
Using, contributing.
We do contribute, but we need to do more of contributing. But yeah, we have, like, whenever we come up with something new, we try to write academic papers or even publish our code on GitHub so that others can take advantage of that as well.
That's awesome.
Building our projects, we use open source software pretty much.
Cool.
That's otherwise specified by a client or something, right?
Really cool. Other questions? All right, let's give them another one more question.
I guess sort of broadly, like what are the big interests from clients when it comes to AI? Is it automating existing business processes? Is it sort of new things like?
For us, a lot of cases are to improve their current process, or making a better decision. Making a better decision. So that could be cost savings, or improving efficiency, or they have existing AI models, but they want to make it more robust, like non-responsible, unbiased, or even performance improvement. That's a great question. Thank you.
All right, folks. Another round of applause.